Hello students, today we are going to see the chapter light. Before we get started, let us see an interesting video. Nature is just amazing, right? What made us feel so? The video was very engaging. Maybe the sounds, maybe the music, or maybe the beauty of the visuals that we saw. But the most engaging part of all of that was that the visuals. The visuals were so engaging and so beautiful to watch. This leads us to an interesting question. What makes us see things? What makes us see the trees, the animals, the classroom, and whatever you see around you, right? So this makes us lead to a very interesting question. What makes us see things? Everything that we see around us is due to the presence of light. Light enters our eyes, and that's how we see the things around us. Whenever light falls on an object and then that light reaches our eyes, that makes us see those things. Our eyes gives us the sense of sight. So the eyes are a very important part in seeing the things around us. The well-known saying you must have heard, Tamasoma Jyotirgamaya, which means from darkness lead me to light. The Bible verse from Genesis also says, let there be light. In our culture, light signifies prosperity, goodness, knowledge. So it is indeed, light is indeed an amazing source of energy, an amazing form of energy. So it is interesting and important that we learn more about light. So let us get started. What have you learned about light in your lower classes? We have learned that light is a form of energy. We have learned that light always travels in a straight line. And we have also learned that the sun is the biggest source of light on earth. Can you think of some other sources of light? The sun, as we told, is a wonderful source of light. A light bulb, a lit candle, LED lights, and even lasers are all sources of light. Now imagine that you are in a dark room with no lights at all. What do you see? Do you see anything? Absolutely nothing. We see absolutely nothing in a room with no light source, which means that it is extremely important that we have light source to see anything, to have the sense of vision. Objects can be seen only if light from some source strikes on that object and bounces back into our eyes. For example, if I want to see my hands, light from some source should come and strike my hand and then bounce back into my eyes. This process of light striking an object and then bouncing back is known as reflection of light. Around us, light is reflected by all the objects like fruits, trees, people, etc. You can see the words in your book because light from some source is coming and bouncing off that page into your eyes. That makes us see the words and read them. Light rays striking the page are reflected off in many directions, and those rays which enter our eyes makes us read them. In class 7th, you have learned that any polished surface can act as a mirror. What a mirror does is, when light is incident on a mirror, it changes the direction of light. Let us see how mirrors change the direction of light. These are given by the laws of reflection. A light ray reflecting from a mirror obeys the two laws of reflection. The first law states that a light ray reflecting from a mirror, the angle of incidence is equal to the angle of reflection. Let us see what this means. The light ray incident on a plane mirror is called incident ray, as you can see in the figure. The light ray that reflects from the mirror is called the reflected ray. Draw a line that is perpendicular to the mirror surface where the light ray strikes. This is called the normal to the surface. The angle between the incident ray and the normal is called the angle of incidence. This is represented by angle I. The reflected light ray forms an angle with the normal, which is called the angle of reflection. This is denoted by angle R. According to the first law of reflection, the angle of incidence is equal to the angle of reflection. In other words, angle I equal to angle R. Let us do an activity to compare the angle of incidence and the angle of reflection and actually see whether this law of reflection is.
Observing the result of the experiment, you will clearly see that the angle of incidence equal to the angle of reflection. This is called the first law of reflection.
Well, that was an interesting activity. From this activity, I am sure you must have learned that the angle of reflection always holds. For the 30°, 45° and 60° angles of incidence, the angles of reflection are 30°, 45° and 60° respectively. So, we have learned that the first law of reflection is actually valid.
Now observe incident ray, reflected ray and normal. All these three lines lie on a same plane. So, we can say incident ray, reflected ray and the normal at the point of incidence lie in a same plane. We call this as second law of reflection. Can you tell in which direction the light falling on the surface will be reflected? I think now you get the answer for this. Yes, light falling on the surface will be reflected in such a way that the angle of incident is equal to the angle of reflection. Do this experiment in your lab and prove the law of reflection for various angles of incidence.
Now let us do an activity to see how an image is formed in a plane mirror. Place a lighted candle in front of a plane mirror. See the flame of the candle in the mirror. It appears as if a similar candle is placed behind the mirror. The candle which appears behind the mirror is called the image of the candle formed by the mirror. The candle itself is called the object. Now move the candle to different positions in front of the mirror. Observe the image in each case. Now let us recall some features of an image formed by a plane mirror which you have learned in class 7. Was the image formed by the plane mirror upright or was it upside down? The image is upright. Was the image of the same size as the object? Yes, the image appears to be the same size as the object. Did the image appear at the same distance behind the mirror as the object was in front of it? Indeed, the image appears to be the same distance behind the mirror as the object is in front of it. Can the image be obtained on a screen? No, the image that is obtained in a plane mirror cannot be obtained on a screen. Image formation on a plane mirror. Now let us understand how an image is formed in a plane mirror. The image formed by a plane mirror is a result of how our brain processes the light rays that enters our eyes. Although the light rays are bounced off the mirror's surface, our brain interprets them as having followed the path. This can be seen by the dashed lines in the figure. In other words, our brain always assumes that light rays travel in straight lines without changing direction. This makes the reflected light rays look as if they are coming from behind the mirror, even though there is no source of light there. The image also appears to be at the same distance behind the mirror as the object is in front of the mirror. Suppose you stand in front of a mirror and raise your right hand. You will see that in the mirror, the image of yourself, the left hand is actually raised instead of the right. This process is called lateral inversion. The left side of the object appears to be the right side of the image. Regular and diffused reflection. Why can you see your reflection in some surfaces and not others? For example, you can see your reflection on a mirror, but you cannot see on a table. Why does a shiny piece of metal make a good mirror, but a piece of paper does not? The answer is, it depends on the smoothness of each surface. When parallel light rays are reflected from a smooth surface, the smooth surface acts like a plane mirror and the reflected rays remain parallel to the surface. This reflection is known as regular reflection. Reflection from mirrors is an example of regular reflection. However, in the case of a rough surface, parallel rays from a light source are reflected in many different directions, as you can see in the diagram. This reflection is called diffused or irregular reflection. It is due to the irregularities on the reflecting surface that diffused or irregular reflection takes place. For example, from a paper or a cardboard or your table, etc. Luminous and non-luminous objects. We know that some objects like a light bulb or a candle or even some interesting plants give off their own light. Such objects are called luminous objects. In other words, objects that give off their own light are known as luminous objects. Examples of luminous objects include the sun, fire, a lit candle, an electric lamp, laser, etc. We also know that there are objects, although they do not have their own light, they reflect light from other sources. This makes us see all the objects around us. For example, you see me because light from some source is being reflected from my face to you. Such objects which do not give their own light, but instead reflects the light from some other object is known as non-luminous or illuminated objects. The non-luminous objects are visible because of luminous objects. Examples are planets, fruits, birds, the moon, etc. So, students, let us summarize whatever we have learned in this lesson. Light makes things visible to our eyes. Light rays reflecting from a mirror obey the laws of reflection. The laws of reflection state that 1. The angle of incidence is equal to the angle of reflection. 2. The incident ray, the normal and the reflected ray at the point of incidence all lie in the same plane. The image formed by a plane mirror is upright. It is virtual and it is of the same size as the object. The image is at the same distance behind the mirror as the object is in front of it. Image formed by a plane mirror undergoes lateral inversion. A regular reflection is produced by a smooth surface such as a mirror. A rough surface forms a diffuse reflection, and such reflections are caused by things such as a paper or a cardboard, etc. Objects can be classified into two types: luminous objects which give off their own light, and non-luminous objects which gives or which reflects light from other luminous objects. So, today we learned about the reflection of light. In the next class, we will see much more about reflection of light and also learn more things about the light that is given off by the sun. Thank you.